Hi all, my name is Debayan, and I'm a PhD student at Michigan State University, working under the supervision of Professor Anil Jain. And today I will be presenting our work on face recognition, primates in the wild, not primitives. I don't know how that got printed there. So in 2008, the International Union for Conservation of Nature came up with a very detailed report on the threatened species around the world, and then they concluded that global diversity is very, very severely threatened, with 22% of mammal species which are regarded as critically endangered, or vulnerable. Primates, which are an order of mammals, are also very endangered, where 60% of all primate species and 91% of lemurs are critically endangered. So lemurs and primates, some primates, they are natives only to the island of Madagascar, where they suffer regularly from overhunting because their meat is regarded as a delicacy over there. Similarly, there's golden monkeys and chimpanzees across Africa, which also suffer from overhunting and habitat loss. So clearly there is a need for us to halt and sort of conserve these primates. And to do that, all conservation efforts require the process of tracking the individuals. And in addition, researchers and conservational biologists also use methods to track individuals, to conduct any longitudinal studies regarding the population health and safety and group dynamics, heritability, effect of traits. For all of these methods, we need a way to track these individuals. Current methods involve using collars or tags, which are essentially just GPS chips around the necks of these individuals. There are a certain number of issues with these methods. Number one is that they could be costly, so where these collars could cost around $400 to $4,000 US. And then the other issue is that we have found that these methods are very invasive to an already threatened species. They can lead to stress, injury, and even death in certain occasions. And the last issue is that there's a growing concern for primate trafficking. It is a booming business where humans capture these animals and sell them and buy them online around the world. It has been estimated around 23,000 great apes were lost between 2005 and 2011 due to illegal trade. And a mere number, which is only 27 arrests, have been made in connection with such trades. So we are looking for a method which is non-invasive to these species. It should also be reliable and robust and automatic, so it can be deployed in the field. And researchers can use this to track individual primates. To this effort, we collected a data set of 3 different primate species. The first one involves lemurs, where I went to the Duke Lemur Conservatory in North Carolina, and I got around 3,000 images of 129 subjects, where each individual has around 7 to 42 images. And then our collaborator in Rwanda collected images for golden monkeys. There's around 1,450 images of 49 subjects, and each of these subjects have around 2 to 120 images. Similarly, for chimpanzees, we actually found a semi-large data set, which is publicly available, which contains around 5,500 images and of 90 subjects. And each individual here has around 300 to 300 images. So the first step that involves in any face recognition system is to actually properly align the face images. For this purpose, we explored the similarity transformation by actually manually annotating these face images using 3 landmarks, which are the left eye, the right eye, and the chin, or the mouth. And these work very effectively, and so we use the similarity transform. And for the CNN architectures, we explored various different architectures, including the state-of-the-art ones for human face recognition. But they all suffer from overfitting due to the small size of our data sets. But what we noticed is if we reduce the number of parameters, we can get very effective results. For this, we actually used SphereNet, but we modified it in a couple of ways. We just made it sparser and wider using group convolutions and an increased number of channels. And you can also see the feature maps across each of 4 convolutional layers, and we have a final fully connected layer at the end. So the experimental results show that the architecture I just described, we call it PrimNet, outperforms most of the human face recognition architectures out there. For the sphere face and FaceNet, we actually even experimented with using a architecture that has been trained for human faces and then fine-tuning on Primates, which doesn't work as well either. So training from scratch on these Primates work much better. We can achieve around 93.7% close set identification accuracy for lemurs, for instance. And as a consequence of lowering the number of parameters, we also get a much smaller model size, which can fit very effectively on mobile devices. PrimNet is only around 3.9 megabytes big, and it can do inference in 23 milliseconds per image. So as I mentioned, we actually kept this whole mobile app in mind while designing our architecture so that it could fit in a phone, and researchers in the wild could actually use it in the field. So we designed PrimID, which is available on the Google Play Store. This is being used in various different conservations across Africa, and we're constantly updating and modifying the software. And currently it supports 3 species, but we're extending it to multiple species. It can do identification as well as verification on the phone, and we don't need any internet for this. Is all offline. So in conclusion, we demonstrated a way which achieves pretty decent identification accuracy, and it can be also generalized to other primate species. The architecture is small enough to fit in a mobile device and perform identification on the device itself. We call it PrimID. For more information, please visit us in our demo and presentation. Thank you.
Any question for the speaker?
Okay. Thank you. I understood that there is high potential in phone-based capturing images, but what do you think about feasibility in the wild, and how would it be easy to approach all these animals with the phone?
Yeah, so currently we have researchers that work closely with these animals. So it is sort of a constrained scenario where the animals are aware of the people that are working with them. But we're now going to deploy it in security cameras, which are set up across the conservation and so on and so forth. So we will see how that works out.
Other questions?